Hey, Kyle here with Maple Systems. Welcome to another Maple Systems video training series. Hey there, in this video I'm going to cover how to use ACLs for enhanced network security using one of the Maple Systems Lite Managed industrial network switches. What is an ACL? Well, an ACL is an access control list. It's a set of rules that decides who or what can access something and what they can do. At layer 2 or L2, ACLs can block packets based on their source and destination MAC addresses. If a packet matches a rule, it gets denied or dropped. So if multiple rules match, the system looks at the priority. The rule with the highest priority decides what happens to the packet. So what is layer 2? Layer 2, or L2, is the data link layer in the OSI model of networking. Layer 1 is the physical layer. That's the actual wires, cables, signals, or radio waves carrying the data. So layer 2, or the data link layer, the layer that makes sure data can move between devices directly connected to the same network. It uses MAC addresses, which are unique IDs burned into the network cards to identify devices. So the switches operate mainly at layer 2. They look at the MAC addresses on each packet and decide where to send it inside a local network or a LAN. And it ensures that the data gets delivered to the right device without interfering with others. So layer 2 is the local delivery using MAC addresses. So you want to think of it kind of like a guest list at a club. So the VIPs, which maybe is IP address 192.168.110, can enter the main hall, which is server A, at any time. All other guests are blocked from the main hall. Then regular members, which is 192.168.10/24, can go to the lounge or the printer, but not the main hall. So there's also layer 3. So what is layer 3? Layer 3, or L3, is the network layer in the OSI model. At this layer, the focus is on how data moves between different networks. So key points for this: it uses IP addresses instead, so IPv4, IPv6 to identify devices. Routing decides the best path for packets to travel from a source to a destination across multiple networks. So routers and layer 3 switches operate here. Packet forwarding based on destination IP, not physical hardware addresses. And fragmentation reassembly, it breaks large packets into smaller ones if necessary for transport. So imagine a factory conveyor system with sensors and gates. So the ACL is like the set of rules programmed into the control system that decides which products are allowed to move down the conveyor and which should be rejected. So at layer 2, the system checks the product's barcode or label, which is the MAC address. If that address matches a rejection rule, the gate pushes it off the line and it gets denied. If that product triggers multiple sensors or rules, the system will then follow the highest priority rule to decide whether the product passes or gets rejected. For layer 3, the system looks at the shipping address and destination information printed on the package, so like an IP address. If the address matches a reject rule, the gate diverts it off the line or denies it. If a product matches multiple rules, the system applies the highest priority rule, again, to decide whether the package continues or is rejected. So in short, layer 3 ACLs act like a quality control system, just like layer 2, that makes decisions based on where the package is coming from and where it's going, not just what it looks like on the outside. Now in MapleLink Lite, go over to the security tab and then click ACL. So here is your access control list configurations. So first you have your profile name. So this is a custom name that you give this ACL rule, so you can recognize it later. So example, you can put here block guest Wi-Fi, for example. And then action, this is where you can permit or drop, or you can have this disabled, of course. So this is what the switch should do when traffic matches this rule. So disable turns the rule off, there's no effect. And you have other common options, which includes permit or drop. So this is kind of like we were talking about with the club setting. You can permit that guest, or you can deny access to that guest or drop them. Ethernet type. So this lets you filter traffic based on what kind of data is at the Ethernet layer. So for example, IPv4, IPv6, ARP, then you have your VLAN. So VLAN lets you apply the rule only within a certain VLAN. This is useful if you want different rules for different groups of devices. Source MAC. This is the unique hardware address of the device sending the traffic. You can filter traffic coming from a specific computer or device. The mask of a source MAC. This is a way to apply the rule to a group or range of MAC addresses instead of just one device. Destination MAC, the hardware address of the device receiving the traffic. So you can control traffic going to a specific device. Then the mask of the destination MAC. This is similar to the source mask, but for destination MACs, groups of devices instead of just one. Source IP, the IP address of the device sending the traffic. So example 192.168.100.50. And then the mask of that source IP. So this defines how many IP addresses should be included, like a range or network. So example 192.168.1.0 through 24 would cover an entire subnet of devices. The destination IP. This is the IP address of the device receiving traffic. So example, a server or printer you want to restrict access to. And then the mask of that destination IP. This is just like the source mask, but for destination IPs, it lets you apply the rule to an entire range or subnet. Source application. This lets you filter traffic based on the type of application or service being used, like HTTP for web, FTP for file transfer, etc. Destination application. This is the same as above, but for the application/service that the destination device is using. The source interface, this is the physical port or interface on the switch where the traffic enters. So this lets you restrict rules to certain switch ports. And then you would click apply to save and activate the ACL rule you created or changed, and refresh. This reloads the page to show the most current ACL settings. And then you would see the status here. So in a real world scenario using layer 2 and layer 3 ACLs in an industrial automation plant, imagine a large automotive manufacturing facility runs a centralized Ethernet network that interconnects production like controllers, robotic arms, HMI stations, and engineering laptops. VLANs are already in place to segment critical systems, but third-party vendors are sometimes given temporary wired access for diagnostics and maintenance. So what's the problem here? During a maintenance window, a contractor connects their laptop to a port in the production VLAN to monitor a robotic controller. So due to misconfiguration, the laptop begins sending network scans, probing SCADA servers and safety relays. Although no systems are compromised, the extra traffic adds jitter to time-sensitive control flows, raising concerns about the lateral movement and operational disruption. So what's the solution here? To strike a balance between security and vendor access, the plant's network engineer applies ACLs directly at the switch ports where non-production devices may connect. So how does that work? Well, for layer 2 ACLs, which are MAC address based, ingress ACLs are configured to deny frames from contractor MAC addresses, attempting to reach MAC addresses belonging to critical automation assets like robotic controllers, safety PLCs, and data historians. This prevents unauthorized device-to-device communication at the Ethernet frame level before IP or higher level traffic is even considered. And then at layer 3, which is IP address based, IP ACLs restrict contractor devices from sending traffic to sensitive IP subnets used by production controllers and SCADA servers. Permits are included by legitimate destinations such as a test PLC or remote support tools, ensuring authorized vendor work isn't interrupted. Then there's also priority handling. So that's safety critical devices. So like safety relays or interlock PLCs. These are covered by explicit deny rules that override general access rules. Normal plant traffic remains unaffected because the ACLs only act on untrusted ingress ports. What is the outcome of all this? Well, for layer 2, if a non-authorized device tries to communicate with protected production components, the switch silently blocks the traffic at the port level before it ever reaches the control system. There's no disruption to normal operations, and vendors can still perform approved tasks. For layer 3, unauthorized attempts to reach protected subnets are blocked at the layer 3 boundary, while legitimate diagnostic and support traffic is permitted still. Well, that wraps up everything today. To get more information, you can visit the How to Use ACLs for Enhanced Network Security tutorial page and visit the Industrial Network Switches page, and this can all be found on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.